Number 5, solve the system of equations by graphing. X plus 1/3 y equals 4, y plus 6 equals negative 3 times x minus 4. So here's what we're going to do. We're going to take this equation, and what we're going to do is we're going to solve those for y, because we want these to be in y equals mx plus b. And so we've graphed a few of these now, and so we're going to work together how to get it looking like this, and then you're going to graph it, and then you're going to be able to pick one of those choices. So let's start with the first one. Okay, once again, we want to get it to be y equals mx plus b. So here's my y. So I'm going to deal with this x first by subtracting it because it's positive. So I'm going to bring down my 1/3 y because these canceled. And then I'm going to rewrite this x term first because I want my mx first. So minus x. And then this 4 is positive. So we're going to go ahead and write that as plus 4. So now I need to get rid of this 1/3, and one way we can do that is we can multiply the equation by 3, and we're going to distribute this 3 to all the terms. So 3 times 1/3, so they cancel. 1/3 of 3 is 1, so that leaves us with a y. 3 times negative x is negative 3x. So there's your slope. You can go ahead and put that right over 1, so now you have your slope. 3 times 4 is 12. So there's your first equation. So you're going to go ahead and graph that. Think about your little man. Think about your y-intercept and your slope and what your little man's going to be doing. All right, let's go to the next one. Y plus 6 equals negative 3x minus 4. Once again, we want to make this into y equals mx plus b form. So this is going to be 2 stages. So first, we want to get rid of these parentheses. So we're going to distribute that negative 3 to both terms. So negative 3 times x is negative 3x. Negative 3 times negative 4. Well, a negative times a negative is a positive. And then 3 times 4 is 12. So we're getting close. Now we have this y plus 6, right? And I want to get this y by itself. So we want to think about how we're going to move this plus 6 to the other side. Well, we're going to do the opposite. We're going to subtract 6. And I'm not going to subtract 6 from the 3x because I can't combine those. Those are unlike terms. I'm going to subtract the 6 from my 12. So now I've subtracted 6 from both sides, but specifically from this one and from this one. So y equals negative 3x. 12 minus 6 is a positive 6. So I want you to notice something. We have y equals negative 3x plus 12, y equals negative 3x plus 6, and this comes over 1 as well. So I want you to look at those two and graph those, and then you're going to notice what happens, and then pick either this, or this. Page 1, number 6. A line passes through the point 0, 7, and 6, 4. A second line passes through the points negative 8, negative 9, and 4, 0. Write the equation for each line and graph the system of equations on a coordinate plane. Label each line on your graph and show all your work. Let's start with the first set of points. I'm going to do this one together, and then you're going to do the next one on your own. So we have the point 0, 7, 6, 4. So remember, this is x1, y1, x2, y2. This is my first point. This is my second point. So the first thing you want to do is you want to find your slope. So you draw your fraction bar, put your first y1, your first x1, minus, second y, second x. 7 minus 4 is 3. 0 minus 6 is negative 6. We can reduce 3 over 6 because this is divisible by 3. This is divisible by 3. So 3 divided by 3 is 1. 6 divided by 3 is 2, and we need that negative. So now this is my slope. M is negative 1 over 2. Then you're going to take the form y equals mx plus b. So remember, this is the equation of a line. And so currently I have m, and now I need b. What we're going to do is we're going to take our m value, and we're going to plug that in, which is negative 1/2. We're going to go up here and we're going to pick an x value. Doesn't matter which one. We're just going to use the first one. So we're going to plug in 0 for x because that's the x value. We're going to take our y value, which is 7, and we're going to plug that in for y. And now we only have a variable b to solve for. So that's great because now I can solve for b. So 0 times -1/2, that's just 0. And then we can see the 0 plus b, so we can just eliminate that. So we get b equals 7. So the next thing we're going to do is we're going to write our equation. So now I have a b, and I have my m value. So I can take this y equals mx plus b, and I can substitute in for m and b only. So I get -1/2 x, and then I have a positive 7. So that's the writing equation part, right? And so you're going to do that for the second set of points, which is -8, -9, and 4, 0. And then you're going to come up with an equation like that. Then you are going to graph both of these. So let me remind you how to graph in case you forgot. So we're going to go up 7. We're going to plot that first point. So 1, 2, 3, 4, 5, 6, 7. So there's our y-intercept because this is my y-axis. Okay, so I plotted 7. Now I'm going to do my slope based off of this point. So I'm going to go down 1, right 2. Down 1, right 2. Down 1, right 2. And I'm just going to get this trend going. And then I'm also going to do the opposite way. So if I went down to the right, I'm going to go up and to the left. So up 1, left 2, up 1, left 2. So now I have enough to trace through this line. And we would label it y equals -1/2 x plus 7. So there's my first line. So you're going to do this whole process for the second line, and then you're going to see what point both of these lines meet at, and that's going to be the answer to the second question. Page 1, number 7. Use the graph shown to estimate the coordinates of the point of intersection of the lines y equals -1/2x and y plus 2x equals -6. Explain your reasoning. So what you want to do is you want to find both these lines. So you need to find this line and you need to find this line. So the first thing is I want you to look at y equals -1/2 x. So this is really y equals -1/2 x plus 0. So pick which line actually goes through 0. Well, there's an obvious one, right? And then you're going to check if it goes down 1, right 2, down 1, right 2. So this looks to be your first line, right? Now let's look at the second line, which is y plus 2x equals -6. So the first thing I notice is we always want it to be in y equals mx plus b form. So this is not in that form, right? Y is not by itself. So we're going to draw our line, and this is a positive 2x, so we're going to subtract it from both sides. So now my 2x's cancel. And then on this side, I have a -2x, so I'm going to write that first because that's my mx, so I always want to put that first. And then I have a -6, and that's my b. So what you need to do is you need to identify this line. Okay, so you're going to find it. So now we know we use this line. So now you have two choices, this one or this one. Remember, use your y-intercept as a guide and use your slope as a guide. Then what you need to do is you need to estimate the coordinates of the point of intersection. So that means you are giving me an xy point where these two lines, this one and this one, cross, and you're going to give me that answer. Page 1, number 8. Solve the following system of equations by graphing. So we're given these two equations, y equals 4, x equals 5. Let's look real quick at this graph over here. And let's imagine I give you the equation x equals 1. So this is very different than what you're used to. So we have a y-axis and we have an x-axis. Well, I know that x equals 1 here, right? This is the point, 1, 0. If I go up here, right, well, what's this point? This is the point 1, 1. If I go up here, this is the point 1, 3. If I go down, what's this point? 1, -2. So what do we notice about all my x values? So where x equals 1, I start to get this vertical line, right? Now, imagine now I have a same graph and I get this equation y equals 2. Well, where does y equal 2? Well, on my y-axis, I know y equals 2 here. How about if I go in this direction here? Well, this is now the point -2, 2. This original one was the point 0, 2. How about if I go over here? Well, this is 1, 2, 3, 4. So this is the point 4, 2. So what are you noticing? 2, 2, 2. And I start to create this straight line here. Well, where do these two lines cross? Right here. And what's the coordinate of this point? Well, your x value is 1, your y value is 2. X value is 1, y value is 2. So your answer is simply 1, 2. That's where they're going to meet. And look, there's your x value here. There's your y value here. Easy peasy. The graph shows one line in a system of equations. It also shows the point of intersection, 6, 7, with the second line of the system. Which of the following equations could be the second line in the system? Show your work. So this is your clue right here, this point, which is 6, 7, and it has an x and a y value. So what you're going to do is you know that this point is a solution to this line, right? Because it lies on that line. I need to know if this point's a solution to one of these. So, well, what can you do? You can check and see if you can have a y value of 7 and an x value of 6. So let's look at this front first. Y is 7. Well, y is 7 we just established from the last problem, right? That if I have a graph like this, and if I go up 1, 2, 3, 4, 5, 6, 7, y equals 7 is all the points that are 7 here, right? So can I go over to the point 6, 7 and hit the line y equals 7? So there's 1, 2, 3, 4, 5, 6. Sure, this point would be a solution for this equation. So that works out. Then what you're going to do is for the others, you're going to actually plug in. So this is going to become 2 times your y value, which is 7, minus 4 times your x value, which is 6. And you're going to see if that equals -10. So you're going to go ahead and evaluate that. Then this one, I'm going to do this over here. You're going to take that y minus 4x equals 7. You're going to plug in your y value, minus plug in your x value, and you're going to see if that equals 7. And you're going to see if this is true or false. So if this is true, then it works. If this is false, then it doesn't. If this is true, then that one works. If it's false, then it doesn't. Describe a line that passes through 6, 7 that has a different number of solutions with the line shown on the graph. Explain your answer. So right now, all of these have one solution. So I want you to think about what's the only other possible set of solutions? Well, we have none, right? We have 1. So if it can't have none because it passes through 6, 7. We already found some that have 1. So the only other possibility is this number, which means infinite set of solutions. And there's only one way to get an infinite set of solutions. So I want you to think about what we talked about in previous problems, and I want you to apply that to this one. But I'll give you a hint. There's the word, I'm going to give you the hint of the word same. Use that as your clue. Good luck.